Okay, so here's the lesson on word problems for chapter 5. Okay? So a rectangle's length is 8 centimeters greater than its width, which is represented by W. So the first thing we can do is draw the rectangle and label its dimensions. So we have a rectangle. The dimensions are its length. I'll use a cursive L to represent that. And width. We already have that stated that that's W. Whenever you enter unknowns into a problem, you always want to say what they are, okay, what they represent. So here I would have length, and here I would have width. Now the problem is, we don't know how to really solve for two variables. We can only really solve for one in grade 9. So I need to represent one of them by something else. So it tells us that the rectangle's length is 8 centimeters greater than its width. So how I would do that is I would say my length, L, is equals 8 centimeters greater than, which means I'm adding that to the width. So now wherever I see an L, I'll put 8 plus W. So I have 8 plus W, 8 plus W. Okay? So that has my rectangle with its dimensions. Next, I'm writing the expression to find its perimeter. So the perimeter is when I add all the sides of any object together. So in this situation, we would go W plus 8 plus W, this side plus this side, plus 8, oops, plus W, plus 8 plus W. So that's my expression. That's it. Finally, we collect like terms. So remember, like term has the same variable, same exponent. So in this situation, we have W. So how many W's are there? Well, there's 1, 2, 3, 4 W's. So we write 4 W, and then we add our other ones. So our constant terms, 8 plus 8, which is 16. So that would be my final answer for the perimeter. Okay, so that's one example. Next example says Peter was cutting rope. His rope started with a length of 3x squared plus 6x minus 8. He cut off x squared minus 5x plus 6. How much rope would be left? Okay. Well, if we start off, let's draw a quick little diagram. Here's my rope, pretty much. Okay. So we have 3x squared plus 6x minus 8. So I take away, and that's your key word, or words as to what operation we're going to do. So when I take away, cut off, we're going to end up subtracting. So I'm going to end up subtracting. Now whenever I'm subtracting something, I put it in brackets, x squared minus 5x plus 6. Okay? Because the key thing we have to remember when we're subtracting is we're going to end up distributing this negative through. Okay? So this I can rewrite again as 3x squared plus 6x minus 8 minus. I'm going to switch each term to the opposite one. So minus x squared plus 5x minus 6. Now I can do this linearly, or I can do it the same way that we've been doing horizontally. So I'm going to just change it up for this one. So 3x squared minus x is 2x squared. 6x plus 5x is plus 11x. Negative x minus 6, negative 8 minus 6 is negative 14. So the final amount of wood that Peter would have, rope that Peter would have left is 2x squared plus 11x minus 14. That's it.